today we are going to discuss about the second library. The NumPy is over, right? Now we are going to discuss about the SymPy or the SymPy. Now, if we go for the introduction part with the SymPy, so this is a package basically used for symbolic computation or a computer algebra system, right? So this is a symbolic computation, and when I say that this is a symbolic computation, what exactly is symbolic computation? So symbolic computation deals with the computation of mathematical objects symbolically. Okay, so this means that the mathematical objects are represented exactly, right, and not approximately. You say so. The mathematical expressions with evaluated variables are left in the symbolic form here in the SymPy. Okay, so we'll just take it with the examples and we'll try to understand these things. All right. So let's just take an example and just start it. Okay. So I think you all know about the math modules and all, right? That's how we find out the things. If we write import math as M, or let it be import mathematics, and if we write math.sqrt, the square root of any particular number, let's say for 5 or something like that, so we get the values, right? If we write math.sqrt of 64, so we get at 8.0. So we get an output of the math from the math module math package. We write up the things, so we get the corresponding output. Similarly, this is for the symbolic computation. As so, here we'll have to import SymPy as SP, or you can take it there as SP or anything. So you can import it as SP or whatever you want, right? So for my prince, it is like good with the SP. Okay. What I do is I'll write this as well as what I do from SymPy. I import everything. Okay. So from the SymPy, I'll be uploading everything. Now,
Hello, sir.
yes, hello.
When you import Simpy as SP, then
Hmm.
all the modules will be there in the program. No, again we need to
No,
import from
we don't
Simpy,
need to write it. We can just write it as this if we write up from
or
SymPy.
else we can remove from Simpy import all the modules.
Yeah, import all this. This sign gives that everything will be imported.
Okay, sir.
Hmm.
But there will be no alias when we do this from Simpy import star.
Yeah, like if you want some particular thing, right? Let's say if you write from NumPy, like from the NumPy import some specific things, like let's say for NumPy import random. So only random could work there from the NumPy like that. So you could write for any specific function if you want. You can write from SymPy, and if I use this asterisk, everything will be imported. So the all functions of the SymPy will work.
Okay.
Okay. So now let's say like we saw the square root of 5 is something there, square root of 64 is something else. Now SymPy is such a symbolic computation package, right? So here if I write just a square root of 8, so this is 2 root 2. If I write square root of 64, so this is 8, right? So the number which is having, or the number which is a complete square will get it outcome as an integer. Okay, like if it is 25, it will be 5, 36, 6, 49, 7, 125, 25, and you'll be getting other things, right? If it is you want to find a cube or a square root, like the things, so you'll be getting the respective answers. But in case if it is not a complete square, then you'll be getting something under root. Okay, so like if you write square root of 5, that is not a complete square. So in that case, you will be getting under root of 5. So for the perfect square, you get the exact answers. But when you compute something for a incomplete square, you will be getting it inside the root. Okay. So if you write the statement as import simpy, and then you work, then you would have to write a simpy dot square root, and then you can write other things. Okay. So since I have imported everything, so I'm not going to write other things. Now there we make symbols, right? That is why it is called a symbolic computation. So here we make symbols, here we make up expressions to solve. Okay, let's say for making any expression you need some variables, right? Like x, y, a, b, c. If you remember the linear algebras and all, right? So you need some variables. Like so, here we called it as the symbols. Okay, rather than of the variables, we call it as symbols. And then with the help of that symbols, we make expressions. So let's write this x and y equals. So when you take one particular symbol, you'll have to write as symbol S capital and then as x. Okay, done. If you see your x, this is a x symbol. But when you take more than one particular symbol, when you want to make more than one variable, like let's say you are taking y and z too, so in that case you will have to write symbols. Okay, and write y and z. If you want to give commas, you can give there. So, so if you see the y, that is this. If you see the z, this is this. Okay. So x, y, and z represents their symbols, right? X, y, and z. Okay, fine. Now to make an expression, right? To make an expression, there must be some LHS, some RHS, and according to that, right? So let's say a very common expression x plus y equals something. So we'll write x plus y. So it is something like x plus y. So let's say ex equals to x square plus y. So we see our expression would be x square plus y. A very basic thing to just represent in the codes. Okay, could be our expression value. Now let's just say we have an expression ex, and we'll write it as x plus 2y. Okay, if you see your expression, it would be x plus 2y, right? Cool. Then we write ex plus 1. So x plus 2y plus 1. Okay, or expression minus x. So only 2y. Okay. So like that you can get other things. Okay. Just 1 minute. So you can make up a binomial expression, trinomial expression, and whatever we do in the mathematics, we can write the things there. So if we write x multiplied by the expression, it gets something as x multiplied by x plus 2y, right? Okay. So we have certain functions as expand, factor, to find or to factorize any expression, to expand any expressions. If I say what is the value of a plus b to the power of 4, right? So we'll be doing it a square plus 2ab plus b square and the square of that kind of thing, right? If I say that what is the value of x plus y, this is an expression. I'm saying x plus y and whole square. So this is x plus y whole square, right? We know the formula x square plus 2y xy plus y square. For the cube to be know, right? But what if I say x plus y to the power of 20, 30, 40? So in that case, what we can do is we can use a function named as expand. Okay, so we'll be using expand function. Fine. If you just see, if I get right there, simply dot, if it gives something there, so is there the expand something? Okay, fine, cool. So see what expand does. If I say that I want to expand this equation, so it will just write down the equation of that, right? By expanding of the things, whatever come, right? So x square plus 2xy plus y square. Similarly, if you say that you want to expand an equation and let it be any kind of equation, right? So x plus y plus z to the power of 3. So this could be the equation. So a plus b plus c whole cube. A plus b plus c whole cube, a plus b plus c to the power of 30. Right. So even you will get an expanded form to the power of 30. So this is the power of the simp we are having. Right. Just hold it's something lagged on. Yeah. So this is the total outcome of x plus y plus z to the power of 30. Right. So you'll get total mathematical outputs very clearly. This is a rule of an expandations, right? So what is the value of x square plus y square? If we say we want to expand x square plus y square, sorry. So just this is an expression, right? That is x square plus y square. Okay. Now let's just make it something here more. So 2. So this is x square plus 2y square. Okay. This is an equation. Now among this equation, like if this is an equation you're having or any equation, like let's say let someone there. Yeah. So if we write up an equation like of x square y x square y this is multiplied y plus y square z plus z square y. Okay, fine. And this is the equation x square y plus y square z plus y z square. So if you've been asked to factorize this equation, how would you factorize? How would you factorize other things? You could have write it as factor of this equation. Let it be an e equals to this, and you see your what is your e. So this is your e you're having. So factor of e particularly. So this is the factorization. Okay, kind of right. So if again I take my expressions, if again I take my expressions up there, e, and I write it to be x plus 2y. Okay. Now again I'm going to use this expand. Okay. So let's say expanded form is equals to expand of this x multiplied by ex or e. So if I see my expanded, it would be x square plus 2xy. Okay. Now if I write a factor of my expanded form, then it would be x multiplied by x plus 2y, right? That is the actual value of this e expanded, right? So this is like how we represent the basic algebras thing in the SIMP with the help of this. Okay. Now you can even go for finding up the trigonometric problems or integration or uh, let's say differentiation. Okay, so why we use this simply we saw that there we can do with all of the things, right? So why we use the SIMP? So there are many computer algebra systems out there. Okay, so there are many problems which could take many time. So to reduce up the things, we have been using this library in a very good manner. Okay, next. So let's see next thing. So the symbols I think is very clear to you, right? What about the symbols? What about the expanded forms and all? Okay, fine. So if you write it as, so every time remember that when you want to make more than one symbol, that is to be kept as symbols, and when you want a particular symbol, then that case you will have to write as capital S and symbol, not S. Only symbol will be there, right? Now we are going to see about the substitute. Okay, so what this substitute does exactly. So to change the value of a symbol in an expression, we use the substitute function. Now, how it helps? Let's say there is expression, and let it be x plus 1, right? And if I see my expression, it is x plus 1. But if I say that ex dot substitute the value of this x 2, so it would be, right, in place of x, what is there? 3. That is 2 plus 1 is equals to 3. Okay, or you can even write that if we substitute this value of x by y, it would be y plus 1. So these things, right? And what is this equal sign give? There are some equal signs that is very important, right? So this equal is having its own importance. If I write it as x plus 1 is equals to 4, so that is false, right? Which is used for equality. If you know, equality testing is given up there for this, right? Right. But what if I want to make an equation, and when I want to write that x plus 1 should be equals to 4? I can relate it with this x plus 1. If I write it as x plus 1 is equals to 4, so I'll get an error out there immediately, right? That is, this can't assign to any operators, right? So you haven't used two operators there, and you can't just use this syntax to write up the things. Okay. So in that case, what to be done? So there we have another function, particularly called as for the equation. So this can be used to create some symbolic equalities. If we write as equation, and we say our equation to be x plus 1, okay, and this is equals to 4. So if we run this, we'll get that x plus 1 is equals to 4, right? Okay, so we can even write it as this can be an equation where we can write that x plus y whole square, x plus y whole square could be equals to x square plus y square plus sorry 2xy, and this is the form, right? So like this is the form we see up there, everything on the books and what you have been studied till now, right? So we can make it like this. Okay, so this is the use of this equation. Okay, then so let's just take a more example, like you have some uh, let's say some equations, and you want to find some solutions with respect to that, right? And I'll make you see that how these things work exactly. Like if we have a very big questions, how we are going to solve these things up, right? I'll just show you some of the major questions we will be just doing up there, right? And remember, you will be having one test of the SIMP, okay, like tomorrow evening. You will be having a test of this, and that's very important because this is one of the libraries which will take more usage than the pandas and the SciPy and the machine learning thing, right? Because in the machine learning also you are going to represent, like it is not important to go, but I prefer the things, right? When you apply any machine learning model, we'll be doing it with the regression, right? So with the regression, when we'll see there are some of the methods like mean squares and some statistic parts are there. So to represent those things manually inside this notebook and finding up the formulas and all, we can do with the help of the simpy, right? So let's take some symbols A and B and C and let it to be symbols of this A, B, C. So you don't have to remember all the formulas and all, right? You don't have to be remember. If you don't remember the formula, use the expand function, it will work for you. If you don't remember the trigonometric formula, use there are various functions I will be giving you today, okay? And we'll be extending the class today after 9 to, right? Because simply cannot be completed within 1 hour, right? So we'll be extending up, okay? So ABC is symbols with ABC, okay? Now that is to be done. And if I see my A, if I see my B, that will be the same of the things, right? So if I say my A is equals to x plus 1 whole square, I have to find this. So what is my A? X plus 1 whole square. And I define my B to be x square plus, or I'll just write it as expand of A. I'm not going to just define up the things, right? So B is the expand of A. So what is B? X square plus 2x plus 1. Now, if we just want to simplify this x plus 1 whole square minus b, right? If I say that I want to calculate a minus b, so the expression is minus x square minus 2x plus x plus 1 whole square minus 1. So try to understand other things. If we just break these things, it will be plus and completely doing the cancellations and you'll be getting 0. But you are not getting any result. You are getting an expression over there that is a minus b leads to this. But what is the value? I need the value. I will not require any equations, right? So we just need only the values instead of the expressions. So if it for a simplification terms, we'll be using simplify, and simplify a minus b will give you the value that is 0. Okay, let's say there's c and this is x square minus 2x plus 1. So this is your c. So if we just simplify a plus c, so this is the value, right? So this is the simplify function, right? So if you have any algebraic expression and you want to simplify it, so we can do with the function of the simplify and you can find it other things. So there is also a method called as equals that test if two expressions are equal by evaluating them, you can say numerically at some random points. Let's say that a is equals to this cos of x square minus sine of x square. Okay, so what is my a? Minus sine square x plus cos square x, right? And let's say my b is equals to cos 2x. Okay, so this is my b, that is cos 2x. If I write that, if I want to check like test two expressions are equal or not, so this is cos 2x and this is cos square x minus sine square x, and I'm going to check whether this both equation are like whether this both term or equations or expressions are equal or not. So I'll write a equals b, that results as true. So that is equal. Okay, so you may have noticed that being used as exponentiations, right, give you some exponentiation value instead of when you use this standard term. When what we use, right, when we use any messaging apps or like this, we used to write this power, right, instead of using this two double asterisks over there, right? So in Python that represents a logical exclusive, right? So in simply if you write it as 1, that is true or false, it would be true. right? So in simply it is like if we just normally use the things, this is written as that much, right? So here in simply we have integer. If you want to write something in integer, so just write that you want integer of 34.5, 34. You want float of 23 something, right? Infinity. 1 minute. That is 0 0. So infinite. Okay, and they can get up the things like this. Okay, so let's say you want some rational number or a fraction to be represented. So rational of 1 by 2 would give some rational numbers, or even here it is written as half. Okay, right as this half. So it is half exactly. Or you want any infinite or any nan numbers, it would be nan. Okay, that is a nan number, or any ones or zeros, 1 or 0 kind of thing, right? These are the basic ones which are needed up the for doing some calculations even. Okay, now moving up next. So you have seen all the basic operations till now. Let's just explore it more, right? So one of the most common thing, like what the very first I have given you, that was the substitution method, right? That you write any equation and you use the subs to find to like substitute the values what you write, right? So if I write an expression and let it be x to the power of y, and we just run this, so you'll be getting 1 minute. Modding simply go from this system, and okay, wrote something different. So this is x to the power of y. Okay. Now if I write expr is equals to this epxr dot substitute the values of x with y, right? Parenthesis expr would be y to the power of y, and if I write expr equals epxr, and I write that I want to substitute this y with x to the power of y. So you can see your expr will be y x to the raise x to the power of y and such things, right? So this is how substitution works. If I write an equation of a sine x square, sine 2x, cos 2x, sine x square plus cos x square. So if I write sine square x square plus cos x square. So this is sine square x plus cos square x, right? And if this is a trigonometric function, and if I use that, I want to expand. Okay, let's just take it as e. So this is an equation, right? And this is an equation. And if I say I want to expand this equation, this will be still the sine square x plus the cos square x. Okay. So what we want to do is we want to expand the trigonometric equation of this e. Okay. See, we want to expand some trigonometric equation, and this would lead actually to 1, right? So let's just edit it something, and let's say this is sine 2x and cos 2x. So it will give 2 sine x cos x plus this, right? So expanding sine square x plus cos square x, what it will give you exactly if you see. So that is trig exempt, we'll see it later onwards, right? That is, if I write sine x square, that is solving some trigonometric identities. So that was not an expression, that was an identity to be solved on. So cos x square, so that will give you the value. Okay, there's some so that is 1, right? We'll go in this function later onwards. So for expanding any trigonometric formulas and all, you can use expand trigonometry and you'll be getting other things right there. So in this E, if I write that E dot substitute the value of this all sine 2x with the value of 2 multiplied by the sine x and multiplied by the cos x. So what will the equation, that is 2 sine x cos x plus cos 2x in place of the things. Okay, right. So that works accordingly, like whatever you write, whatever you use to substitute. So I think substitute would have been clear to you. Okay, all right. Now if I say that you have some strings, and we learned in the Python that we can't operate anything with the string, if you remember of the things, right? If you just remember of that, if you write that this is string 2 and multiplying it by 3, so we'll give 2, 2 and 2, right? In case of not giving us x, giving it as a 2, right? Okay, 1 minute. Okay, so instead of getting it as a numerical value, we are getting some strings, right? But in case, like in simply, if we have some strings and we want some values to be given, so let's say this is an expression, right? Ex, and we write it as, let's say this is x squared plus y squared and plus 2, or let it be, okay, just write it monomial one. So x squared plus, let's say 3x or minus 3 by 2. So what is this ex exactly? So x is square plus 3x minus 3 by 2. So what I say that I want to simplify, not simplify. Okay, there's a difference between the things. So the simplify function, right? This can be used to convert the strings into simplify, right? That is, it would just use the expressions to convert this in simply expressions. Okay, so that you can just then operate the things. So simplify. This is simplify. This is SYM. Simplify. Nice. So simplifying an expression will give you the value that is, like, expression will be generated up, right? That is x square plus 3x minus 3 by 2. Now this is your exactly equation you want to right, simplify and all what you want to do it with this. So this would be your expression. Now you can find up, like you want to solve this, you want to simplify this, you can use simplify. This expr would give you, okay, this is not a good one. So you can use the solve method with this expr to find something, and possible values are minus 3 by 2 plus square root of 15 by 2 and minus under square root of 15 by 2 minus 3 by 2. So the total values, we'll be seeing it what solve exactly does. Okay, don't worry for that. So solve actually solves very big problems there. Okay, fine. So moving up to the next function. So next we have all these integrals and differentiations and all the printing functions, how to print up the things, right? So printing is not very important for us, right? We are just going to go for the simplifications and all, right? So what simplify does, it attempts to apply all the functions required, all the calculations required to perform any linear expression or anything, right? So if you write simplify, if you remember the things, that is sine x square plus cos x square, so we'll get it as 1, right? That is how simplification works. So simplifying the terms right there. If you write simplify a term as x square plus 2 multiplied by x plus 1. So x square plus 2x plus 1. Some terms, right? So if you want to give a polynomial or a rational function simplification, so there you can use the expands, or you can use the factors, or if you have a list and you want to factor it with that respect, you can also give it with those things, right? Okay. So I'm talking about, let's say if you have a list, right? So we can use with the factor of a list. So factor list, okay, this is underscore of a list, right? And then you can write up your elements x square, right? Let's say this is x square z, this is z, like 4x y z, okay? And let's say it's 4 multiplied by y multiplied by 2 multiplied by z, and so you want to factor this in a kind of a list, so it would be the result uh, x square z plus 4xyz plus 4y. Okay, this to be the square, let's take it there, and this would be the result, right? That is 1 and z plus 1 factor, and then it to be there. But if you write this expression and you take it as a complete factor, not as a list factor, right? If you just write it as a factor of this all, so you just get a factorization, that is z x plus y 2y whole square, and here you are getting a factor inside a list, right? That is z plus z1 and then x plus 2y whole square, okay, right? So that is expand can be used for, like, if you have cos x plus sin x whole square, sines some formulas, right? We'll be getting up with those things. Now we have some function called as cancel. So cancel will take any rational numbers and will put it into the standard canonical form, that is p by q, or the fractional form you can say, where the p and the q are the expanded polynomials and they will not have any common factors. Let's say if I write an equation that is x square plus 2x plus 1, that is x plus 1 whole square, right? So this is one equation, and we'll make a bracket there, and we'll divide it by x square plus dx. Okay, so what is this equation particularly? That is x square plus 2x plus 1 divided by the x square plus x. So if we just factorize this whole equation, so what is the value? That is x plus 1 or by x. So even using the factor, we can also write it that we want to cancel this equation, right? What we do is cancel the facts, right? So we will get the same thing, okay? That is x plus 1 and by the x, okay, fine. Similarly, if I write that you want to cancel something, uh, you might know of the things, right? That is like if you are having something in the above as sin x plus cos x, sin x minus cos x, and divided by sin square x plus cos square x. So it was completely 1, right? Okay. Similarly, right, if I write it as 3 multiplied by x by 2 minus 2, so 3x by 2 minus 2, okay, let's just take it, the expression is cancel, or let's take first the expression 1 by 2, sorry, 1 by x plus 3 multiplied by x by 2 minus 2 divided by x minus 4. So this is the expression, that is 3x by 2 by x minus 4 plus 1 by x, and you want to factorize this, or like you want to solve this. So you can easily use this solve and ex to get out the results, that is minus 4 by 3 and 2. And you can easily write this factor even to solve this x, and it will be x minus 2, 3x plus 4, the 2x, then x minus 4. So we'll be using this cancel method to find the ex, and we'll be coming to our equation, that is 3x square minus 2x minus 8 by 2x square minus 8x and all the factors of that, right? So is this kind of a boring session? Because doing a lot of mathematics there, but this is a basic one. Anyone feeling a bored?
No, no. When we solve it, it's interesting only.
Yes, nice. So kindly don't get bored because there are some things to do in the mathematics. Okay. So like you can use this factorizations and all. Okay. So if you know about the partial fractions and all, right, that is we use the partial fractions to write up the equations and solving up into some differentiations and all. So let's say there is an expression that is 4 multiplied by x multiplied to the power of 3. So 4x cubed plus 21x square, okay, and plus 10x plus 12. So this is a kind of an expression. If we see that this is 4x cubed plus 21x square and plus 10x minus plus 12, right? So what we do is we'll just divide it by something else. So let it be x to the power of 4 plus 5x cubed plus 5x square, okay, and then 4x. Something in that. Okay, this is plus, and the expression would be 4x cubed plus 21x square. Okay, fine. Then plus 10x plus 12, right? Then x to the power of 4 plus 5x cubed plus 5x square and plus 4x. Fine. So this is your function, right? If you have been asked to cancel and solve these things, so ex would be same, right? It will not be going to write anything. If you write this solve this equation, you'll be probably getting up the results, but not as much nice, right? So this we are going to use a function called as apart. So apart performs a partial fraction decomposition of any rational function. So if we write that we want an apart, that is a partial fraction of this ex. So we'll get a 2x minus 1 by x square plus x plus 1 minus 1. So just it is a one line code to solve any big problem, right? So trigonometric simplification we'll be seeing applies if we write an a cos of x, right? This is a basic thing. So cos of a cos of x, that is x, if you know of the things, right? So a sine of 1, that is pi by 2. So as I say, that will be using trigsem, that will be used to simplify expressions using trigonometric identities that we use basically. Okay, so trigsem is being used up there to find out the things. So let's say you have a equation trigsem. So I'll be giving you the bit of questions to practice up with this. So let's say cos x square, and sorry, this is the square, okay, and plus sin h square xh. So it would be cos h 2x, right, kind of thing, okay. So similarly, if you want to expand any, so whatever the trigonometric equation would be, it will be able to solve the things, right? If we write up tan of x plus, what is that, tan of a plus b? What is tan of a plus b? So if you write, you want to expand this tan of x plus y. So, oh sorry, this is underscore trigonometry. So it would be tan x plus tan y, and then 1 minus tan x tan y, isn't it, right? So even if you don't remember other things, you can write up the equation and it will just expand it for you. So it would be also for the case of an integration, differentiation formulas if you don't remember. So what I felt practically of the things, right? Like when was when I solved my class 12 board paper of my mathematics, I took almost, I was just left with some 15 minutes, right, when I was giving my boards. But when I learned this library and I implement it with my paper, it almost took around 35 minutes to just complete up the total paper. So that is interesting actually. So you can apply up the very big things, right? So instead of solving up the things manually or checking it from the book, right? If you know Python and if you know basic mathematics, right? Implementing of the functions, then I suggest like even if you go with this laptop in any good college and you can solve up their problems with this one line, and that's it how it does. So you can just see over the things and right click and see the mathematical codes, so it will be done right, what are the operations being written and how it is being done, so everything is clear with this all. Okay, moving up next, right? So we can apply the formulas for the trigonometry to find out the things. Now, if we talk about the powers, that is x to the power of a, x to the power of b, and all that exponentiation things, right? So there we have something as power, or you say power is imp, or you say powers imp, right? This powers imp implies or applies this identities of whatever I'm going to write now, right? So let's say that is normal identities. What there we have x to the power of y multiplied by x to the power of z will give x to the power of y plus z and all. Okay, powers imp of right, if I write x to the power of a and multiply by x to the power of b. So what is it? This is sorry. So okay, we have defined something a and b. What is this a? So a is this and b is this. So let's do one thing. A and b would be the symbols of a b. So let's just run this statement again, and we'll get this. If we just write up this one, not just taking it from the pause, and if we just write this and run, so it will get 8x8. How we are going to solve this manually? That is x multiplied by a to the like x to the power of a plus b, right? Isn't it? We are just going to solve it by that, right? Okay, so that is how we use up the things, right? So if you have square root of x, that is square root of x. If you write square root of x into y, so square root of x y, right? So that is how it's written. But if you want y in other square root, x in other square root, what you will say, right? In that case, what you will say? Square root of x multiplied by this some square root of y, square root of xy multiplied by square root of y, and so does it will be done, right? So if you want to expand power, if you want to expand the bases, even you can do with that context. Okay, fine. So we're just moving to the next, right? That is exponentiations and logarithms. Okay, now logarithms is very easy. If I write this as logarithms of a, x is not defined. Log x. So what is this ln and all, right? So this is a natural logarithm, also called as ln. Okay, it looks like a Lincoln sign, right? So this will be used to find the logarithmic values. So there are some basic expressions for a log, that is, it is written as log of x multiplied by y. Okay, and this is equals to, right? If you remember the equations, even if you don't remember, no need to worry, you can expand up the things and you can find it there. So this is an equation that log x is equals to this, right? If you know, and this is also an equation that this log x to the power of n is equals to n multiplied by this log x, right? So I'm not going to write n because I haven't taken this n. So log of x to the power of a will give you a log x, and like these are the common things you have written. The formulas we know, right? So like if you have a log and this is x to the power of y, and you don't know the formula, the basic thing, you don't know the formula now. So what you can do is expand underscore of this logarithm value, this log of y. So expanding the logarithmic value of log of xy will give you the result whatever it is. Like we know this is log x plus log y, and why it is not coming? Hmm. Expand the log of this, and it's fine. Okay. No. 1 minute. Hmm. Okay. Let's do one thing. So I think this could be due to the values we have to define. So for the log, we will have to define it by it. Okay, this is positive. Hmm. Yeah. So there are some conditions to define up for the x and y because there are some sufficient conditions for the identities. So to hold up the values, we'll have to define x, y as positive and n what we are going to use as the real. Okay, and let's see it now. Fine, done. Okay, so you have to define up your things in another way, right? That is, it must be positive. Okay, and the symbols you are going to use. If I say that this is expand of log of this log of x to the power of n. So in that case, it is log n plus log x, or if it is log x to the power of n, that is n log x particularly. So there should be the things, okay, right? Now, if you have more than one logarithmic expressions and you want to combine them, so you can use log combine, and that could run as log combine. Nice. So log combine of, let's say, log of x plus this log of y, and we'll run this and you will get it as log xy, right? So that is all how you solve some logarithm values. Now, when I say if you are given some questions, right? This you have been given some 5 zeros, and you have been asked to make 120 with this. Do any of the mathematical calculations you can do and make 120 with the use of 500. Sorry, 5 zeros. What's the common thing we are going to use? Which operation we are going to use? Like if you want to make 120 with 5 zeros. Anyone there? It's very simple. Any mathematical operation. You can use addition, subtraction, multiplication, division, any mathematical operation you know till now. You have been given 5 zeros and you want 120. It's very easy, right? You guys have might not might you must have read the factorials, right? What is the factorial of a zero? If you remember, that is 1. So what if I write a factorial of why this always comes? Right? What if I write a factorial of 0 for 5 times? That would be 5. And what if I find a factorial of such thing? That would be 120. Hmm? So that is exactly. So what is a factorial of this x? X factorial, right? That is x factorial. So that is how to just do the factorials and all. Okay, if you remember the things, right? So factorial of any binomial like kind of x divided by, sorry, this is x divided by x minus 1, and this is right, factorial of this is will be leading it to 1, and all those things. Okay, yeah. So next thing, right, I believe that you will not be getting bored. Now coming up to the calculus part, so it is very important to see the derivatives, integrals, limits, series, expansions, Fourier transforms, and all. Because in the real life implementation, we are going to apply this integration and differentiation. When like we were learning, we have been informed that this is one of the things that we are going to apply in our real life, like the trigonometries and all, right? So it is also important to get things done here. Okay. Now, for finding up any derivatives, so for finding derivatives, we are going to use the diff function. Oh my god, this is again. So you can use this diff function to find to differentiate any expression. So we want to differentiate cos x. So cos x differentiation is minus sine x, right? So want to differentiate any such equation, x squared plus 2, 2x. And you can write with respect to x or y whatever you want. So with respect of y it will be 0 obviously, but with respect to x it will be 2x. Okay, if you remember the differentiations, right? So if I differentiate, this is differentiate an equation, and if I write that the equation as x to the y z, that is x y z, differentiation of x y z. Hmm, oh, we haven't given any expression. So let's say we want to differentiate this x y z with respect to x y. And that is why this is coming up, x y and z. That is like how many times you are going to differentiate of the things. That is what I am trying to say. Uh, let's say you have an expression x to the power of 4, and we differentiate this, so we get 4x cubed. What if I say we are going to differentiate for 3 times, we'll get 24x, right? So that in the case we are going to do with the x and y, but it's not working. Alright, fine, no issues, right? Similarly, like if you want a derivative of any expression, so you write it as derivative of expression, and that your expression would be x to the power of 4. So d by dx of 4, right? And there are some printing methods if you initialize those things. So if we just initialize this printing method, and we say that we are going to use Unicode as to be true, and now again we'll run this derivative, and we'll write x to the power of 4. So you'll it sometimes will find it something different, right? I'll show you where you'll be getting up some different methods of the derivatives and all. Okay, fine. So a derivative can also be defined as like derivative, and you want to do it, right? So x to the power of 4. Derivative is not defined. Okay. Okay, it was not installed. No issues. Okay, so you can even integrate or even differentiate. So integration is also easy. If you just integrate, let's just take some differentiation yeah, just take any of the common question for the differentiation. We'll try to solve with that respect of this. Okay. Any equation up there? Okay. So differentiation of this x cube plus 2x with respect to under root x. Okay, find x cube plus 2x with under root x. So differentiation. So first we'll see the expression, right? We want a derivative of an expression. Okay, an expression which is x cube plus what is it? Okay, remember the x cube plus 2x and under root x. 2x. Is it with respect to under root x? No, it is x cube plus 2x under root x. Okay, so x cube plus 2x under root of x. Okay, I think that is the expression, right? X cube plus 2x and under root of x. Now we want to find derivative of this ex. And this could be dy dx of x cube plus 2x by under root of x. That is very easy to just write up and differentiate with respect to x. Would get the answer under root of 3x square plus n. Now, fine, that is very easy. And that's what I say that when I was solving it took almost 35 minutes to solve the things. Any big operation, right? If we just take any good derivative. Okay, so find d square y dx square. So you can even find up the double differentiations, right? So doing double differentiations, equation is y equals x square plus 1 to the power of 4. Cool. So y equals x square plus 1. So equation is y equals, what was that? I usually forget the expressions. So x square plus 1 to the power of 4, I think, right? So is it? Yeah, I think that's an equation. Yeah, t square y by dx square. That is double differentiation you are going to do about this. So this is your e particularly. Okay, this is my e. So you can see of the real life problems we are going to do. Even you are a medical student, you can perform very good at there, right? So this is e, right? And we just want to solve this equation manually, not doing the differentiations and all. So if you just solve this e, we'll get the solutions to be as this, right? No, not as this. Sorry, this is like a equation you're having still now, right? So we want to differentiate it. Okay. So if we write derivative of this e, derivative of an equation. So this equation will give us this. But what if I write derivative of this? So the derivative with respect to equations, right? And let's see if we get some correct answers or not if we just differentiate it. Copy. So 48 x square plus 1 plus 1, and is it so? No. 4x square, what is it exactly? The answer is coming there. So let's just first perform the differentiation of this, then again differentiating this. So with respect it is going to be differentiating.
Next answer was also correct.
Mm-hmm.
The third equation in the right side of the row, 8x square plus 1 is there.
Yeah,
Solution is there. Plus 48x square, third equation. Above that equation. Below this one, what you are holding?
Yeah. Yes.
Equation. It is similar to the what we have got, I think.
It is correct. I can see the 48. What is it? 40. Yeah, it is
X
48
square on
x square. Okay, you have a very good sight. I'm not having so much. Alright, so I think we got the correct expression, right? That is 48 x square plus 1. Let me just match it there. Uh, and is it 8 x square plus 1 whole cube? He has given cube. Okay, fine. Then he has factorized the thing, I think. And he has factorized this. So let's see the factorizations too. 8x x square plus 1 whole cube, isn't it? 8x x square plus 1 whole. And what is the thing now? That would be x cube. So we have got the values, right? So you can see we can even solve some good problems related to the differentiations, right? How you get in your examiners, right? So one who is like, this is very useful for the like the professors, the teachers, not useful for the students, right? Because they can only use these things when they work with some problems to check up their answers and all, right? So like the teachers could make a very good advantage with this. They will not have to go through the book, even if it is given a wrong answer in the book, you will get always the correct answer here if you write up the things clearly. Okay, fine. Moving up. So, how many of you are from the PCM? How many from the biology? How many from the commerce? Everyone, I believe everyone from the PCM. Anyone from non-PCM background? Mechanical engineering. Cool. So I believe that even if a student is from a medical science, right, then too it is very easy for him just to find out the answers, even if you don't know mathematics. So just a class, because I had a workshop of a school, a DPS Raipur, there was a DPS Durga, Sali, and there was a student. There were students from the class 6th and 7th doing all these trigonometric problems, and they were doing very nicely. Like actually, they asked to just how to solve this trigonometric and all. One student asked, so I just raised that. Okay, we make you see how this works, and they solved it. Right, so they are doing good now. Right? It's easy. Okay, now in SIMP, this equates an infinite sign. Okay, and that is 2o, you write in the lowercase and you get an infinite sign. So similarly for the differentiation we saw, we have integrations and integrals, if you remember. So we write integrate any cos x. What is the integration of cos x with respect to x? That is sin x. And if we just define the upper limits, lower limits, and if you remember of the things, right, the integration of the upper limit and the lower limit. So if we write an integral or an exponentiation of minus x, okay, and then define the upper limit, that is x 0 and infinite. Upper limits and the lower limits to be defined. Let's see what comes. So integration of from 0 to infinite of e of minus x of dx. Okay, that is very nice to just express. Now, if you want an integration of this, sorry, we have to write it as that we want to integrate this equation. Numeral denominators. Okay, isn't it something wrong there? Integrate explanation of x 0 to this. Causing errors. Okay, cool. That is an error. So the value is to be 1, right? So integrating up with some reference to it. Okay, Fine. This is how we do. So similarly, if you just integrate the exponentiations of x square minus y square with some minus infinite values to infinite, you get the things. So that you put up the lower limits and the upper limits, and you see up the things. Let's say you are integrating x to the power of x with respect to x. That is integrate of x to the power of x, very easy. And you will write integral of this x to the power of x with respect to x. So this is integral of this x to the power of x with respect to dx, right? The expressions you are getting up there. So if you define up your x, you'll be getting the values. If you write the integral of this log x to the square with respect to the x, you know log x square plus the integral of this, what is being the integral of this, right? So if we just, what is the integration of this? So you can just write up that you want to integrate. So integrate this, and this is the value. You can even use, if you have an expression, so write the expression and then you can write do the integration. That is do it just, right? So it will do it there. What is the problem? Okay, cool. Triple abscess is no further to it. This is not having any to it. Okay, yeah, sorry. So you'll have to write it as integral of this, and then you can perform. Still has no attribute of an as coefficient. Cool. So integral of log x square, and with respect to x, so what is the error? Alright, leave it. We'll see your net onwards. What is my x? Okay. Alright, we'll have to change now, right? So this is the integrations and what you get, guys. Okay, now coming up to the limits, right? So if we just see a basic integration problem, so any integration problem, there are a lot of big problems. Any good question of integration? Yes, there are various steps going with the solve. What is the equation? 2x cube and then logarithmic values of this x square plus 1, the dx. Right? So ln stands for the natural logarithmic value. You remember, right? And okay, remember the equation, right? Because I forget the equations. 2x cube log of x square plus 1. I will try to remember. 2x cube plus log of x square plus 1. 2x cube plus log of x square plus 1, and this is this 2 what is double integer. So okay, I think I have changed my x, right? So I'll have to make it a symbol. So 2x cube logarithmic value of x square plus 1 is the same equation there, 2x cube logarithmic x plus 1. Okay, and limit is 0 to 1, integrating this. Okay, 1 by 4 is the answer. Okay, see, so this is my e, and that's an expression. So this is e, and now we'll be giving some limits to this. So we'll try to solve this. So it is particularly an integral of this e, and the limits of this with respect to x is from 0 to 1, and this is the integral of 2x. Isn't it the same problem? 2x cube log this, and with respect to 0 to 1, yeah. So
There is no plus sign. X cube multiplied with logarithmic value.
it's multiplied.
Yes, yes.
Oh no, thank you. this is again the value, and this and this and this. Fine. Now, well, we'll have to integrate this, right? And 1/4. How many steps we skipped? One, two, three, four, five, almost 5 to 6 steps. Yeah, and we got the answers. So I personally feel that if I get a chance again to go in the class 12 mathematics exam with my laptop, so I'll be giving us a talk, right? In 10 minutes, I believe that I'll be completing exam in 15 to 20 minutes over. And with accurate 100% results. Like everything I can solve here. There is nothing, right, which is being kept like talk about limits, factorials, permutation combinations, probabilities, algebras, everything. Nothing is being left. So it's very nice, right? Okay, moving next. Okay, now uh, we are going to see about the limits. Now limits are also very easy, like we have seen about the integration division. So here we can compute up the things just by writing, like if I write a limit of this sine of the x with pi x, right, and putting up the intervals, so that is 1, right, that is limit of x tending to x of 0 and that all. So expressing it up, right, that is an expression, limit function particularly. So you can find up the things with that. I mean, you can even substitute the values to find up all those things. So if you write, if you want an expression, you can write it capital L, and you can find it about limit of x to the 0, tending to the 0, but sine x by x, and you find the limits of this. Like you can write it as a limit, and if you want to express your terms there as, let's say this is a cos of an x, okay, so cos x minus 1 and divide by x respect to x and 0. Okay, so cos x minus 1 by x, and you want the limit of x tending to the 0. That has been done. So any difficult problems of an integration can be solved within one line, right? Okay, see, we have got some super difficult question of IITG. So, well, it is a super difficult question. Okay, let me take a snap of this and then I can write this. Okay. Okay, let's just solve this IIT super difficult problem. Let's take how many time it takes to solve a super problem. Cool. What we require is tan x, cot x, e. Okay, e is the exponentiation there, and dt and all. Okay. Cool. So t is being required. So the equation is like integral of t divided by 1 plus t square, with respect to t. So like q, from where this q comes. So t. So integration of t with not sorry, this is 1 plus t square. Okay, so t square plus 1. This is like okay, and then it's being given some limits. Okay, so there are some limits now. Limits are as from t 1 by e tan of this x. 1 minute. Invalid limits t of 1. Something we have written wrong. Expression writing is wrong, I think. So let's take this as the expression. This is my e, isn't it? So t by 1 plus t square, that is an expression. Okay, it's fine. Now let me see it again. So t by 1 plus t square is the expression. Okay, limits are 1 by e to the tan x. 1 by e to the tan x. So let us take it as an integral, and integral of this expression, and the limits are going to be, with respect to this t, it is going to be from what is it, 1 by, let's see if it comes from 1 first, 1 to tan of x. So tan of t, I think. What is it? Tan of x. Okay, so x was also to be defined up there. It is a difficult one. Let's take it x. Symbol of this, we haven't writing the equations properly, so that is working. Okay. Okay, come on now. Okay, so this is, I think, 1 by e with respect to tan x. Cool. And this is minus exp. That is again. This e has been initialized with this. Okay, so e to the power of minus 1, it will be taking up there. Is it e to the power of minus 1? No. Yeah, okay, fine. E to the power of minus 1. So this is done, and next we have plus. So cool. Done one part. EF1 is integral of 1 by e to cot x. Alright, just been changing up the things now. Okay, let's just copy this all and write up the things. 1 minute. What is this? Same question, t multiplied by 1 plus t squared. So equation writing is taking some time. T multiplied by this. Let's see the equation. EF1. This is t squared by. Okay, not again. This is something t multiplied by, I think, here. So what is it? Okay, it is nothing. 1. 1 by t multiplied by 1 plus t square. So 1 by t multiplied by 1 plus t square. Is it like what I'm doing? 1 minute. 1 by t multiplied by 1 plus t square. Fine, it is the same thing. 1 by t 1 plus t square with respect to dt. It is t plus t cube exactly. So 1 by t plus t cube.
Put brackets for 1. Whole 1 divided by t square plus.
Oh, bracket was missing.
Yes.
Okay, that is t square plus t cube, or t plus t cube. Okay, 1 by t plus t cube. 1 by t plus t cube. This is the equation. 1 by t plus t cube. So from there, if we take t, so it would be t plus 1 plus t square. Fine. So if I take this back, got it. Fine. Alright. So it was making up the problems. Okay. So, well, that is the second equation. X is defined, and the limits are 1 to e and then cot of x. 1 to e and then cot of x. Okay, so that will be same as for this. So integral of ef1, sorry, not ef1, integral of this factor of ef1, and what is that? 1 to e till cot x. Cot x. Previous we have given any wrong limit, yeah. So this to be defined as, very nice, done. Okay, so this is my h and this is my g, and let's see my g and h. G plus h. Done. So writing up the equation is only taking the time. So e of minus 1 till the tan x, this, and just see the things if it is correct or not. 1 plus t square, t by 1 plus t square of dt, t by 1 plus t square of dt, 1 by e to the tan x, and 1 plus t square. Cool. So this is the equation to be integrated. Okay, and this is the value we are getting. Definite integration. Okay, where it is being posted? Doubt not. What is the answer the students are getting? Alright, this is a video. X square.
Help.
What is this?
क्या है? Please.
It is a different very problem. Is this the answer or this the question? What is this? The cot of x and integrating this g plus h. If we integrate it separately, Please come this one plus t expressions. Okay. Okay. The A and X we are going to give it to be true. 'Where we define the t. Yeah. Seven to 48 has been run. G has been given, which has been given. Integrator g plus h specifies dummy variable for 1 plus t plus t1 2 and integral. Yeah. So there were some errors between this t. T. What this t gives. Integration of g is uh, integration of g is logarithmic value of this part is multivariate partial fraction decompositions, non-intermittent errors. Double integration. Okay, I didn't get this question. What is asking there? So this would be the answer. What we are getting up here, like integrate of g and integrate of this h. Okay, so there is a problem in the h. Alright, we'll look this tomorrow, right? I think there are some problems. Or there's something what I will be missing. Okay, no issues. Just see complete up that limits and all. Okay, but why it is not working? Finite is uh, is integrating something finite. Because for differentiation we have some definite integration like this function would go integrate finite. Okay. Alright, we'll see it later. Nice question. But what this question says, x square by this integration of x square by x and x plus cos x square. X square by x sin x plus x sin x cos x. I think something is not working up there. There is an integral. Integral is also giving the same. Okay. So, initializing printing, so I've given that. Okay. Hmm. Multivariate. Okay. All right. I have to look on this problem. Night. Okay, I'll look at that. Okay. So like these are the some methods what we do with the simply. Okay. So I'll be sharing this file with you. What you do is practice. Okay.